Given the integral of 0 to 3, f of x dx equals 4, and the integral of 3 to 6, f of x dx equals -1, evaluate the following using the equations at the top of the page. So for the first one, we have the integral of 3 to 3, f of x dx, and you can see that it equals 0, because if you look at the first equation at the top of the page, if it goes from a to a, then the answer is 0. For the next one, we have the integral of 6 to 3, f of x dx, which equals 1. And in the directions, we can see that the integral of 3 to 6, f of x dx equals -1. And the second equation at the top of the page shows that if it's the same but the a and the b are reversed, then the answer is negative. So -1 times a negative is +1, and that's why the answer is 1. For the next one, we have the integral of 3 to 6, -5 f of x dx. So how we solve this one is we bring the -5 out of the integral. So it's -5, the integral of 3 to 6 f of x dx, which is -5 times -1, which is 5. For the next one, we have the integral of 0 to 6 f of x dx, and since we don't have any instructions for 0 to 6, we use the very last equation at the top of the page and we split it up, so we do the integral of 0 to 3 and the integral of 3 to 6, and we get 3 for our answer. And for the very last one, we have the integral of -2 to 1 f of x plus 2 dx. And since this equation isn't in the directions either, we have to make the x plus 2 equal to u, and du is equal to dx. So from there, we know that x is equal to -2, so we plug -2 into the u equation, and we get 0. So u is now equal to 0. And then we do the same thing for 1, and we do 1 plus 2, which is 3. So now we have another u that's equal to 3. And then we have a new equation, which is the integral of 0 to 3 f of u du, and that is equal to 4, because in the directions we have the integral of 0 to 3 f of x dx, which is equal to 4, and they're the same thing.